Vast Haven-1 Commercial Space Station Report. Overview. The Vast Haven-1 space station, heralded as the world's first commercial space station, is on track for launch aboard a SpaceX Falcon 9 rocket targeted for no earlier than August 2025. Developed by VAST, this innovative facility is designed to support both private astronauts and governmental missions, featuring a human-centric innovation laboratory aimed at scientific research and in-space manufacturing. Key features and specifications. Dimensions and capacity. Diameter, 4.4 meters. Height, 10.1 meters. Habitable volume, 45 cubic meters. Pressurized volume, 80 cubic meters. Total mass, approximately 14,000 kilograms. Crew capacity, up to 4 members. Facilities and equipment. Observation window, a 1.1 meter domed window for enhanced observation. Interior features, includes personal sleeping quarters, a deployable communal table, and advanced research facilities. Power supply, 12 solar panels delivering a total peak power of 13.2 kilowatts. Connectivity, enhanced internet access through SpaceX's Starlink service. Mission structure. Mission duration. Each mission on Haven-1 is planned for a duration of 2 weeks, allowing crew members to engage in advanced scientific research and experiments in microgravity. Crew and reservations. The station will offer individual seat reservations or full 4-person crew missions accommodating both U.S. and international astronauts. Future development. VAST plans to develop Haven-1 further, with aspirations to integrate it into a larger multi-module spinning artificial gravity space station in the future. Timeline of events. 1. 2021, VAST is founded to pioneer space habitation technologies. 2. May 10, 2023, announcement of Haven-1 detailing the first crewed mission VAST-1 in collaboration with SpaceX. 3. 2025, targeted launch of Haven-1 on a Falcon 9 rocket, with plans for initial operations as an independent space station. For future aspirations, VAST aims to conduct artificial gravity experiments and ultimately develop a 100-meter-long space station. Common themes. Innovative design. The design and capabilities of Haven-1 emphasize its dual role in promoting scientific exploration and providing commercial spaceflight opportunities. Collaboration with SpaceX. This partnership is crucial, ensuring reliable launch and transport services for missions to the Haven-1 space station. Focus on microgravity research. The station aligns with the increasing interest in commercial space exploration, particularly in scientific research and manufacturing. Diverse perspectives. While various sources highlight common aspects of Haven-1, they differ in emphasis. Source 1 focuses on technical specifications and interior features. Source 2 highlights the collaboration with SpaceX and the broader implications for commercial spaceflight. Source 3 provides a wider view of VAST's long-term vision, including plans for additional modules like Haven-2. Anticipated to begin operations in 2028. Conclusion. The Vast Haven-1 space station represents a significant leap toward the commercialization of space, merging scientific exploration with private enterprise. By establishing a foundation for long-term living and working in space, Haven-1 aims not only to enhance humanity's presence in low Earth orbit but also to pave the way for future advancements in space habitation technology. This ambitious project reflects the evolving landscape of space exploration, where commercial entities play an increasingly vital role in expanding humanity's capabilities beyond Earth. As the launch date approaches, the anticipation surrounding Haven-1 continues to build, promising a new era of innovation and discovery in space. Counterintuitive information in the content about Vast Haven-1 commercial space station. 1. Commercial versus government focus. The idea that a commercial space station can serve both private astronauts and government missions may seem counterintuitive. Traditionally, space exploration has been dominated by government agencies like NASA. However, Haven-1 is positioned to cater to both sectors, suggesting a shift in the paradigm where commercial enterprises are not just supplementing but becoming central to space exploration. 2. Integration of artificial gravity. The ambition to conduct artificial gravity experiments aboard Haven-1 could defy common perceptions of microgravity environments being the only focus of space research. Instead of merely adapting to zero-gravity conditions, the station aims to explore how to create artificial gravity which could fundamentally change how humans live and work in space. 3. Commercial space travel for research. The fact that private individuals can participate in research missions may challenge the notion that serious scientific research is exclusively the domain of trained astronauts or scientists. This opens the door for broader participation in space science, emphasizing that commercial space travel is not just about tourism but can include meaningful research contributions from a diverse group of people. For short mission duration, the planned 2-week duration for missions aboard Haven-1 contradicts expectations of longer-term missions typically associated with space stations like the ISS. While the ISS has been used for extended stays, Haven-1's short mission structure implies a model of rapid turnover and high accessibility for a variety of missions. This could signify a new approach to utilizing space stations for transient research and experimentation rather than long-term habitation. 5. Private company building a space station. The very concept of a private company launching and operating a commercial space station was once deemed improbable. The success of Haven-1 challenges the long-standing belief that such endeavors are too complex or expensive for private companies, showcasing a growing trend of privatization in space. 6. Partnership with SpaceX. The reliance on SpaceX for launch services and crew transport may seem logical, yet it indicates a broader trend where established aerospace companies are becoming essential partners for new entrants in the space market. This collaboration may lead to the unexpected outcome that newer companies like VAST can leverage existing technologies and systems rather than developing everything from scratch. 7. Focus on microgravity manufacturing. The emphasis on in-space manufacturing as a core function of Haven-1 contradicts the traditional view of space as primarily a research environment. The potential for manufacturing in microgravity suggests that commercial opportunities may extend beyond scientific research to include industrial applications, which could facilitate a commercial ecosystem in low Earth orbit. 8. Internet access in space. The provision of high-speed internet access through SpaceX's Starlink service aboard Haven-1 challenges the notion that communication in space is limited and unreliable. This development could redefine the operational capabilities of space missions, allowing for real-time data sharing and collaboration that was previously not feasible. 9. Room for growth. The ambitious plans for future modules and a larger spinning artificial gravity space station suggest that Haven-1 is not merely a standalone project but part of a broader vision for space habitation. This long-term perspective may be counterintuitive in an industry often focused on immediate outcomes, indicating that the commercial space sector is thinking expansively about its future. 10. Diverse mission objectives. The range of mission objectives, including government private astronaut missions and payload research, may seem counterintuitive considering the complexity of coordinating such diverse interests. This multifaceted approach could lead to a more dynamic and versatile utilization of space stations, challenging assumptions about the specialization of space missions. In summary, the vast Haven-1 commercial space station embodies several counterintuitive concepts that challenge traditional notions of space exploration, commercialization, and research, potentially signaling a revolutionary shift in how humanity engages with space. The vast Haven-1 commercial space station represents a pivotal moment in the evolution of humanity's presence in space, yet there are significant aspects of this initiative that are often overlooked which merit deeper examination. Here are some critical content points from the report that may not receive the attention they warrant, along with explanations of their significance. 1. Artificial gravity research. Significance. One of the most intriguing and often underappreciated aspects of the Haven-1 project is its potential for artificial gravity experiments. The report hints at future plans for a multi-module spinning artificial gravity station, The significance of this lies in the long-term implications for human health and performance in space. Prolonged exposure to microgravity can lead to muscle atrophy, bone density loss, and various health issues. Establishing a viable artificial gravity environment could allow for longer missions and more sustainable habitation in space, which is essential for future endeavors including Mars colonization and beyond. 2. Microgravity Innovation Laboratory. Significance. The station's role as a microgravity research and innovation laboratory is emphasized, yet many may underestimate the impact this could have on various scientific fields. The unique environment of microgravity allows for experiments that cannot be conducted on Earth, leading to breakthroughs in materials science, pharmaceuticals, and manufacturing. This capability could significantly enhance our technological advancements and economic opportunities in space, making space not just a destination but a productive environment. 3. Diverse mission opportunities. Significance. The report outlines the availability of mission opportunities for both private astronauts and government entities, with a focus on scientific research in space, manufacturing, and payload missions. This dual focus on commercial and governmental missions is significant because it positions Haven-1 as a versatile platform that can cater to a wide range of stakeholders, thereby fostering collaboration between private companies and public agencies. This synergy could lead to innovative partnerships and accelerate the pace of discovery and commercial viability in space. 4. SpaceX partnership and technological integration. Significance. The collaboration with SpaceX is highlighted as a critical aspect of the project. However, the implications of this partnership go beyond mere logistics. SpaceX's experience and technology represent a significant leap in the reliability and cost-effectiveness of access to space. The integration of Starlink for onboard internet access is another critical feature, as it ensures continuous connectivity, which is essential for both operational efficiency and the psychological well-being of astronauts. This integration of advanced communication technologies may also pave the way for more complex operations, including remote research collaborations and real-time data sharing with Earth-based scientists. 5. Commercialization of space. Significance. While the report emphasizes the commercial nature of Haven-1, the broader implications of this commercialization are often overlooked. The first commercial space station marks a shift in how space is utilized, transitioning from primarily governmental activities to private enterprises. This could stimulate a new market for space tourism, research, and manufacturing, thus creating economic opportunities and spurring innovation. The establishment of a commercial presence in low Earth orbit could also encourage more players to enter the space industry, ultimately reducing costs and increasing the pace of exploration and development. 6. Sustainability and long-term habitation. Significance. The long-term vision articulated by VAST includes the development of a fully operational multi-module space station that could succeed the International Space Station (ISS). This focus on sustainability and the potential for long-term habitation in space is crucial, especially as Earth faces numerous challenges. Developing technologies and habitats that allow humans to thrive in space can alleviate some of the pressures on Earth's resources and offer new avenues for exploration and habitation. 7. Training and preparedness for astronauts. Significance. The emphasis on comprehensive training for astronauts, including emergency preparedness and mission simulations, is vital, yet might not be fully appreciated. Such training ensures that crew members are not only skilled in operating within the Haven-1 environment but also adept at handling unexpected challenges that may arise during missions. This preparedness is crucial for the success of any long-duration spaceflight and the safety of the crew, especially in commercial ventures where diverse backgrounds and experiences may be present among participants. 8. Cultural and psychological aspects of space travel. Significance. The design elements of Haven-1, such as the large observation window and communal spaces, point to an understanding of the cultural and psychological needs of its occupants. While technical specifications are critical, the mental well-being of astronauts is equally important for mission success. Addressing these factors could lead to improved crew dynamics and overall satisfaction during missions, which is especially relevant as more private individuals embark on space travel. In conclusion, the vast Haven-1 commercial space station is not just a technological endeavor, it represents a transformative shift in how humanity interacts with space. The overlooked aspects discussed are significant because they underscore the broader implications of commercial spaceflight, the potential for scientific advancements, and the necessity of preparing for long-term human presence beyond Earth. As we stand on the brink of a new era in space exploration, recognizing and addressing these factors will be crucial for the future of humanity in space. 1. Pioneering commercial space exploration. The vast Haven-1 commercial space station is positioned to revolutionize space travel by combining scientific research with commercial opportunities. As the first of its kind, it signifies a shift towards privatized space stations, allowing both private astronauts and government missions to utilize its facilities. This dual role enhances accessibility to space for various stakeholders, from private individuals to international space agencies. Promoting a new era of commercial space exploration. 2. Technical specifications and innovations. Haven-1 boasts impressive technical features, including a habitable volume of 45 cubic meters, a 1.1 meter domed window for observation, and solar panels providing peak power of 13.2 kilowatts. Its design incorporates human-centric elements such as personal sleeping quarters and communal spaces aimed at enhancing the living experience in microgravity. Additionally, the station's ability to support in-space manufacturing and scientific research positions it as a significant platform for advancing technologies and knowledge in space. 3. Strategic partnership with SpaceX. The collaboration between VAST and SpaceX is crucial to the success of Haven-1. Utilizing SpaceX's Falcon 9 rocket for launch and Dragon spacecraft for crew transport ensures reliability and safety. This partnership not only facilitates the logistics of space missions but also marks a historical milestone, as the first commercial space station will be launched and operated in conjunction with a commercial rocket company. This synergy is expected to accelerate the development and operational capacity of commercial space stations. 4. Long-term vision and future developments. VAST's ambitious roadmap extends beyond Haven-1, envisioning a larger multi-module artificial gravity space station. The plan includes conducting artificial gravity experiments and developing Haven-2 for broader missions by 2028. This long-term vision positions VAST as a key player in the future of space habitation, aiming to create sustainable environments for humans in space, ultimately contributing to humanity's ability to live and work beyond Earth. 1. Skylab 1973 to 1974. Skylab was the United States' first space station launched by NASA in 1973. It served as a laboratory for scientific research in space and as a platform for astronauts to conduct experiments in microgravity. Skylab had a habitable volume of approximately 90 cubic meters and supported 3 crewed missions where astronauts conducted experiments in solar astronomy, Earth observation, and life sciences. Skylab's success in demonstrating the feasibility of long-duration human spaceflight laid the groundwork for future space stations, including the International Space Station ISS. 2. Mir 1986 to 2001. The Mir space station, operated by the Soviet Union and later Russia, was a significant milestone in space habitation and research. Launched in 1986, Mir was the first modular space station and allowed for long-term human presence in space, hosting numerous international crews over its operational life. Mir was a platform for a wide array of scientific experiments, technology demonstrations, and international cooperation in space exploration. Its modular design influenced the development of the ISS, showcasing the potential for collaborative space missions. 3. International Space Station ISS 1998 present. The ISS is a multinational collaborative project involving space agencies from the United States, NASA, Russia, Roscosmos, Europe, ESA, Japan, JAXA, and Canada, CSA. Since its first module was launched in 1998, the ISS has served as a microgravity laboratory for scientific research, technology development, and international cooperation in space. It has been continuously inhabited since November 2000. Hosting astronauts from various countries and conducting thousands of experiments across diverse fields such as biology, physics, and earth science. The ISS represents a successful model for long-term human habitation in low Earth orbit and has paved the way for future commercial space endeavors similar to the goals of the Haven-1 commercial space station. Future outlook for vast Haven-1 commercial space station. The launch of the vast Haven-1 commercial space station represents a pivotal moment in the evolution of space exploration, commercial opportunities in low Earth orbit (LEO) and human habitation in space. As we look toward the future, several predictions can be made about the impact, advancements and developments stemming from this groundbreaking initiative. 1. Expansion of commercial space travel. With Haven-1 serving as the world's first commercial space station, the demand for commercial space travel is expected to grow significantly. The station will not only cater to private astronauts but also accommodate government missions, thus broadening the spectrum of participants in space exploration. As more private individuals and organizations seek to experience space firsthand, we anticipate an increase in the number of commercial launches, paving the way for a new era in space tourism. This trend will likely stimulate a competitive market, with other companies aspiring to develop their own commercial stations or services. 2. Advancements in microgravity research. Haven-1's design includes a human-centric innovation laboratory, making it an ideal platform for conducting advanced scientific research and in-space manufacturing in microgravity. Over the next decade, we can expect a surge of experiments that leverage the unique conditions of space to develop new materials, pharmaceuticals, and technologies. This increased focus on microgravity research will not only advance scientific understanding but may also lead to breakthroughs that can be applied on Earth, particularly in fields like medicine and materials science. 3. Integration into a larger space infrastructure. As VAST progresses toward its goal of building a larger multi-module spinning artificial gravity space station, Haven-1 is anticipated to serve as the first module in this expanding infrastructure. By the late 2020s and early 2030s, we could see Haven-1 connected with additional modules, enhancing its capabilities and accommodating more crew members and experiments. This integration will mark a significant step toward establishing a permanent human presence in LEO, ultimately aiming to succeed the International Space Station ISS. 4. Artificial gravity research. One of the most exciting prospects associated with Haven-1 is the potential for conducting artificial gravity experiments. VAST's long-term vision includes the development of spinning modules designed to create artificial gravity, which is crucial for long-duration human habitation in space. Future research may focus on the physiological impacts of artificial gravity on the human body, which could lead to improved designs for long-term space missions to the Moon, Mars, and beyond. 5. Enhanced international collaboration. The launch of Haven-1 is expected to foster greater international collaboration in space exploration. Given its accessibility to both domestic and international astronauts, the station is likely to become a hub for various space agencies and research institutions. Collaborative projects could emerge focusing on global challenges such as climate change, space debris management, and planetary defense. This cooperation may strengthen international relationships and promote peaceful exploration of outer space. 6. Development of supporting technologies. The operational needs of Haven-1 will drive innovation in various supporting technologies, including life support systems, space habitat design, and in-space propulsion methods. As VAST and its partners refine these technologies, the advancements could have spillover effects benefiting not only future space missions but also terrestrial applications such as sustainable living, energy efficiency, and resource management. 7. Economic growth in the space sector. The establishment of a commercially viable space station like Haven-1 is likely to stimulate economic growth in the burgeoning space sector. Increased investment in space technologies, support services, and infrastructure will create job opportunities in engineering, manufacturing, and research. The economic ripple effect can extend to ancillary industries such as tourism and entertainment. As more companies explore opportunities in the space economy. 8. Public engagement and interest in space. The advent of commercial space stations will likely reignite public interest in space exploration. As individuals from diverse backgrounds travel to space for scientific, philanthropic, or recreational purposes, their experiences can inspire the next generation of scientists, engineers, and explorers. Enhanced media coverage and storytelling around these missions will further engage the public, fostering a culture of curiosity and support for space exploration endeavors. Conclusion. The vast Haven-1 commercial space station is set to play a transformative role in the future of space exploration research and commercial opportunities. As we approach the launch and subsequent missions, the implications of its success extend far beyond the station itself. By fostering advancements in technology, encouraging international collaboration, and inspiring public engagement, Haven-1 is positioned to be a catalyst for a new era in humanity's journey into space. The next decade will be crucial in shaping the legacy of Haven-1 and its contributions to the broader goals of long-term human habitation and exploration beyond our planet.